Welcome to Spruce Science. Today, we're excited to introduce you to our Coaxial Electrospinner and its spinneret with 2 concentric needles. You will see how we use the Coaxial Electrospinner to create electrospun fiber mats with red markers. This capability has exciting potential for targeted drug delivery systems, such as using electrospun fibers loaded with therapeutic drugs for wound dressing. We can't wait to show you the final result, so stay tuned. In the rest of the video, we will first provide an overview of the hardware we will be using. Then, we will move on to demonstrating the coaxial electrospinning process in detail. Get ready to see the magic of electrospinning in action. Gathering the electrospun fibers is made easy with the use of the collector. The rotation speed of the collector is adjustable, allowing you to fine-tune your process to achieve the desired results. The assembly is user-friendly and provide a convenient way to collect your electrospun fibers. The Coaxial Spinneret is a unique tool that allows you to mix and match 2 independent flow paths through its 2 concentric needles. These flow paths come together at the tip, providing endless possibilities for creating a variety of fibers. The 2 syringe pumps that are used in the electrospinning process are independent and have been designed to be electrically insulated, allowing them to withstand high voltage. The controller with its analog interface allows you to have intuitive control over the collector and syringe pumps. The adjustable high voltage power supply is a key component of the electrospinning setup, giving you complete control over the output. You can switch between constant voltage mode and constant current mode to suit your specific needs. This particular model can deliver a powerful 30 kilovolts, which is a great range for electrospinning applications. The current output limit is 400 microamps, which is more than sufficient for the electrospinning process and ensures that you have a good fit for your application. To connect the high voltage output to the sample, we will be using the hook clip. Just a friendly reminder to always verify that the high voltage is off and fully discharged before touching any of the equipment. We're going to demonstrate how to use the coaxial electrospinning machine to create compound fibers. To begin, we will use the main syringe pump to deliver a solution of PVP polymer to the center needle. Then, we will use the second syringe pump to deliver red ink to the outer needle. When the 2 elements meet at the tip of the coaxial spinneret under the influence of high voltage, they will combine to form a PVP fiber mat with red markers. This process is driven by an intense electric field, which transforms the polymer solution into fibers as they travel through the air. It's an exciting and simple way to create unique and functional materials using electrospinning. Stay tuned to see the final result of our compound fibers. We are briefly going to talk about the many benefits of using PVP in your electrospinning process. PVP is a synthetic polymer that is soluble in water and alcohols, making it easy to work with and form into films. It attracts and holds on to water molecules from the surrounding environment and has good wetting properties. PVP is a versatile material with high heat resistance and good adhesive properties. It is also non-toxic and acts as a good dispersing agent, helping to prevent settling and clumping of solid or liquid particles. These characteristics makes PVP an excellent choice for a variety of applications in electrospinning. As you can see, the fibers gathered on the collector has a stunning light pink color. Upon closer inspection, You can see that the red ink is uniformly dispersed throughout the mat. It's truly a sight to behold. Everything was going smoothly during the process, but once we turned off the high voltage power supply, a droplet formed at the tip of the needle. As it dripped down onto the fiber, it created a hole in the mat. It's important to be mindful of these potential issues and to have a plan in place to address them. The Electrospun PVP mat with red marker has a fibrous structure and can be easily removed from the collector. This amazing technology allows us to inject one solution into the other at the tip of the needle, where fibers are drawn under an intense electric field. This gives us the flexibility to create a variety of fibers, including coaxial fibers, hollow fibers, compound fibers, or any combinations that we desire. This technology can be utilized in the medical field to deliver therapeutic drugs directly to targeted cells, tissues, or organs. One specific application is the use of PVP fiber mats as wound dressings, as they can help to maintain moisture around wounds and can be enhanced by the addition of therapeutic drugs. Electrospinning has the potential to greatly improve wound dressings through its ability to precisely deliver particles, molecules, or liquids to carrier fibers. This combination of moisture retention and targeted drug delivery can greatly improve the healing process for wounds. Thanks for joining us today. If you have any thoughts on the future of electrospun nanofibers in the medical field, or if you work in the industry and can share some insights with us, please leave a comment below. We would love to hear your perspectives. Don't forget to visit our website for more information. And if you want to show your support for our channel, the best and easiest way is to click the subscribe button and hit the notification bell. It's completely free and easy to do. Just click on the little icon in the corner. Thanks again for watching. We hope to see you again soon.